I am Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. Welcome to the lecture session of image processing. In this session, we are going to discuss fundamental steps in digital image processing. So, the topics what we are going to cover today is different types of images and steps in digital image processing. So first we will discuss about what are different types of images. Now, in general, we will see the number of images. In that, some of the images will be natural images and some of the images will be synthetic images. So generally here, natural images means the images that are captured from the camera, and whereas synthetic images means if there are any operations that are performed on that particular image, that means by using computer, if you are performing any operations on that image, that particular image we call as a synthetic images. So in this class, we will see what are different types of images. So here, images, we have different types. That means the images that are based on the attributes, images based on the color, images based on dimensions, and images based on data types. Again, we will discuss in detail about all these types. So for example, if you consider images based on the attributes, here the images that are based on the attributes, again it is of two types. One is raster images and another one is vector images. So we will be discussing about these two types in detail. And coming to the images based on color, there are different types of images. Again, it is classified into binary images, grayscale images, true color images, and pseudo color images. So we will be discussing about all these in detail in this session. And coming to another type, that is images based on dimensions. Here it is classified into two types. So some of the images comes under two-dimensional images and some of the images comes under three-dimensional. So coming to the data types, here based on the data types, images are again classified into signed integer, unsigned integer, and floating point integer. So these are different classifications in different types of images. Now we will see about each classification in detail. So first we will be discussing about the images based on attributes. So here, images based on attributes. There are two types, there are two classifications. One is raster images and another one is vector graphics. So here, these two differs based on one important term, that is pixel representation. So here, coming to the raster images are completely pixel based. So the quality of the raster images are completely dependent on the number of pixels. That means here, if the number of pixels are more, that particular image resolution will be high. If the number of pixels are less, the resolution of that image will be reduced. So here the raster images are completely pixel based. We can see the pixels in that particular image very clearly. Coming to the vector graphics, it is the basic geometric attributes. It will be using lines and circles in order to describe an image. For example, we can consider here two images are given for the reference. So here these are the examples of raster images. So in this raster images, we can clearly see the pixel representation. So the raster images are pixel based, whereas these two images are called vector graphics. If you consider these two images, vector images, pixel representation is not seen practically. This is the basic difference between raster images and vector graphics. So this comes under the images based on attributes. Now, another type of images are here types of images based on color. So here again it is classified into different types. One is binary images, another one is grayscale images. So here you can see the two example figures are also given. We will discuss how they differ. Here coming to the binary image. So this in order to speak about this binary image, we have to speak about one important term which is called threshold value. So this binary images are completely dependent on this threshold value. So how it is related to this threshold value means, for example, the pixel value which is available in this particular image, it will be comparing with the threshold value. If the pixel value is greater than the threshold value, then the value will be equal to 1. If the pixel value is less than the threshold value, then the value will be equal to 0. Here value will be 1 and 0 means the value of that particular pixel will be 0 and 1. So here in the binary images, they will be represented in the form of bi-level. That's why these binary images are also called as bi-level images. So here bi represents 2. That means the pixel value will be 0 or it may be 1. It is based on the threshold value, compared based on the threshold value. So if the pixel value is 0, it means it will represent black color. If the pixel value is 1, then that particular color represents it is white. So this is the image that comes under binary image. So if you see this image, it is completely based on only two colors, 0 or 1. That is pure black and pure white. No shades of these two colors are available in this particular image. So that is what about this binary images. Coming to the next type, that is grayscale images. So here this grayscale images generally it will be represented in the form of 8 bits. That is, it can be represented in the form of grayscale using 8 bits. So here human visual system can distinguish only 32 different gray levels. So as here it is represented in terms of 8 bits. Generally here 2 power 8, the value is 256. So the pixel values will be ranging from 0 to 255, whereas 0 here represents black and here this 255 represents white. So the value that is present in between these two, that is 127. So this 127 represents the value gray, whereas the remaining values that is present in between this range 0 to 255 will be the combination of the shades of these colors. So if you see, this is an example figure which represents grayscale image. So compared to these two figures, so the quality of this figure is high. So if you see this grayscale image, it is the different shades of colors are available. Different shades of black and white colors are available in this image. Now, another classification, same images based on color. Another classification is true color images. So here, if you see this figure, it consists of entirely all the shades of colors. That's why these true color images are also called full color images. These particular images will be represented with the help of 24 bits. That means we can write this 24 bits as, by dividing this 24 into 3 different channels, we can write this as 888, which will be equal to 254. So this 254 is represented in the form of 3 band images. So here the 3 bands are 8, 8 and 8. So if you want to represent again in terms of 8 bits, you can have here 2 power 8, 2 power 8 and 2 power 8. So generally 2 power 8 value is 256. So you can simply represent this as 256, 256 and 256 value. So we can write this as 256 power 3. These many number of colors are available. All colors will come under this range. So the value of 256 power 3 is, this is the value which is equal to 256 power 3, and these many different shades of colors will be available in this true color images. So if we observe this particular image, all the colors are available in this particular image. So true color images are also called full color images. And another one is here, same images based on color. So another classification is pseudo color images. So pseudo color images are called false color images, like true color images are called full color images. Pseudo color images are called false color images. Because why it is called false color images means some artificial colors will be added in order to represent the image. In order to interpret the image, some artificial colors will be included. So this pseudo color imaging will be used in medical applications. For example, if you consider the Doppler color image, it also comes under a pseudo color image. So if you consider, this is the example image that comes under pseudo color image. Some artificial colors will be added in the image in order to interpret the data. So not only this Doppler color image processing, remote sensing also comes under this pseudo color images. Why? Because in remote sensing, around 3 to 11 bands of electromagnetic spectrum will come under that. So if we consider that range, it is beyond the human eye perception, which is not able to find. So here, in that particular type of applications like remote sensing, this pseudo color image processing can be applied. So all these comes under the images based on color. And next classification is, next types of images are images based on dimensions. So in this type of images, we have two classification. One is 2D images, another one is 3D images, that is 2-dimensional and 3-dimensional images. So what is the main difference between these two types of images are? Generally, the images that we see around us will be in terms of 3D. When it is captured by using a digital devices like camera, in that the image what we are seeing will be converted into 2D. So generally, in digital images are 2D, rectangular array of pixels. So if another dimensions are added like depth or any other characteristics, the 2D images will be converted into 3D images. For example, if you consider 2D images, the basic characteristics of this 2D images will be length and width. So So these are the two characteristics that will be available in the 2D images. Coming to 3D images, along with this length and width, one extra characteristic will be added. That extra characteristic may be height or thickness. Okay. So this is the main difference between 2D and 3D images. So here are the example figures, images that shows 2D and 3D images. So the circle, square, triangle, rectangle, rhombus, all these have been coming under 2D images, because in these we can see only length and width of that images. Whereas coming to these 3D images, along with the length and width, we can also observe the depth of that particular images. So this is the basic difference between 2D and 3D images. And next type of images are images based on data types. So here we have different classifications. Some comes under signed, some are unsigned, some comes under floating point. So here signed and unsigned numbers, here in order to handle negative numbers, this signed and unsigned integers will be used. So for example, if we are representing any data, if you are considering any data which is of 8-bit in size, if you want to represent that 8-bit data, in that 8-bit data, the MSB will be representing 1 bit, and that particular bit will be saying whether that particular number is positive number or negative number, that is signed number or unsigned number. So in this data type, first bit is used to encode whether the number is positive or negative. For example, if we consider 8-bit data, that is n is equal to 8, that particular integer will be representing from 0 to 2 power n minus 1. For example, if n is equal to 8, it will be representing from 0 to 2 power 8 minus 1. So that first bit will be representing whether the number is signed number or unsigned number. Now coming to floating point representation, if we want to represent the data completely in specific notation, then this floating point representation will be used. For example, if you consider the number 1230, it can also be written as 0.123 into 10 power 4. So we have represented, or we are going to store the particular data, this data, in this form. So here, if you are going to write in this form, the value 0.123 will be representing the is called as significand, and the power here is representing the exponent. So these are different types of images. Now coming to one important topic, steps in digital image processing. So here are the different steps that the image has to undergo during digital image processing. So what are different steps here? One is image acquisition, image enhancement, image restoration, color image processing, wavelets and multi-resolution processing, compression and morphological processing. So if we consider all these blocks, the images that are dealing with all these blocks will be outputs. That means if you pass the image in any of these blocks, the output of these blocks, again it will be producing image only. Images will be the outputs of these blocks. And some more blocks are also available here, that is segmentation, representation and description, and object recognition. Coming to these blocks, the outputs of these blocks will be generally here attributes. So here some of the blocks will be giving the outputs as an images. Some of the blocks will be producing the outputs as attributes. So here problem domain represents the input what we are giving. That means the application what we are going to work on. So here all these blocks are available in digital image processing. So seeing all these blocks, it do not mean that the image has to process in all these blocks. Based on the application, the image has to process only selective blocks. So there is no requirement to have all these blocks, and there is no requirement of applying the image to all these blocks. It is completely dependent on the application or the problem domain on what we are working. Based on that particular block should be used. Now we will be discussing about each block in detail, starting from image acquisition to object recognition. So image acquisition, here this is the fundamental block. That is the first block, which is very important. We will be discussing all these blocks, the sequential order. So coming to the first block, that is image acquisition. So image acquisition means acquiring an image, capturing an image. So this is one of the basic step, first step. So it is the most fundamental step in image processing. So using this block, what is the function that will be performed means, this block is going to convert the captured image into digital form. That means here the image what we are capturing using sensors will be the unprocessed image, that is raw image, and that particular image will be completely modified by using the block image acquisition. Because in this image acquisition, one important operation will be done on the image, which is called pre-processing. So what happens if pre-processing is applied on the image? If pre-processing is applied on the image, some operations like scaling, sharpening will be done on the image, so that the noise will be reduced, the image will get clean, the quality of the image will be improved. So the image acquisition, after capturing an image, so the basic components what we are going to use in order to capture the image may be of digital camera, or it may be scanner, or any other device. So after the image is captured by using these devices, that particular image will be imported into the computer, which will be performing this pre-processing operation. After the image is pre-processed, then it is going to give to the next block. So what is the next block here after image acquisition? It is going to give the pre-processed image to the image enhancement block. So after the image gets pre-processed, it is going to the next block, which is called image enhancement. So what is the basic operation that will be done by this image enhancement block? So the image, after being pre-processed, it is going, this image enhancement is going to bring out all the hidden details present in that particular image. That means it is going to do some changes in the image by considering some features of that particular image. So what are the changes that will be done on the image means, on that image the brightness may be increased and or the contrast may be increased. So if you consider, this is an example image for image enhancement. So if you consider this first image, it is very dull, it is not looking bright. So identifying that particular person is somewhat difficult. When it is given to the image enhancement, the output image is the second image. So in this image we can see the brightness and contrast of that particular image have been increased. That features, considering that features, it has been improved. So this image enhancement will be improving the quality of the image, such as increasing the contrast on brightness by reducing the noise. So this is the main operation that will be done in this image enhancement block. And after image enhancement block, the next block is image restoration. So image restoration means it is going to upgrade the input image. It is going to upgrade the input image so that the overall appearance of the image will be improved. So if you consider, this is an example figure we have taken in order to see what is image restoration. So for this image restoration block, if you consider here the first image, okay, so it is not some of the information in this image have been lost, and in order to restore this particular, this is an example of degraded image, we can call it as a degraded image. Some of the information is lost, some of the information is lost in this image. So in order to restore that particular degraded image, we are going to do image restoration operation. After image restoration, this is the output image what we are going to get. So what we have observed in this output image, the degradation have been removed so that the blurring, noise and distortion which is present in the input image have been reduced. And next block in that fundamental steps of image processing is color image processing. So generally now whatever the images that we are processing will be, mostly it will be color images. So color image processing is a famous area because it has increased the use of images of the interest. So what is this color image processing block function? So this color image processing is used to extract some of the important features that is present in that particular image. Basically, the human eye is capable of visualizing some of the primary colors like RGB. So here R stands for red and G stands for green and B stands for blue. So in combination with these three primary colors, some of the additional colors, so in combination with these three colors, some of the additional colors like C, M, Y will be extracted. So here C stands for cyan and M is magenta and Y is yellow. So these are the three primary colors and different combinations of these three primary colors. These are the colors that are visible to the human eye. Coming to the next block in the fundamental steps of image processing, the next block is wavelets and multi-resolution processing. So here what is meant by wavelet? They will be represented in the form of a small waves with a limited duration, and it is used to calculate the wavelet transform which will be providing the time frequency information. And here wavelets lead to multi-resolution processing in which images will be represented with a different degrees of resolution. So here this is the operation that will be performed on this wavelets and multi-resolution processing. And the next important block is compression. So here why we need to compress an image? After performing any operation on the image, that particular image should be stored somewhere, or that particular processed image should be transmitted to some other device. So in order to make this operation, we need to compress an image. So what is the advantage if you compress the image for before storing or before transmitting that image means here. So this compression is the technique which is used to reduce the storage space which is occupied that particular image or bandwidth requirement to transmit that image. So to store that image, we need to spend more amount of memory, or in order to transmit that particular image, more amount of bandwidth here is required. So here, bandwidth, we need to know first what is meant by bandwidth. So here, bandwidth is an amount of data that can be transmitted over the communication channel in particular amount of time is called as bandwidth. So in order to display any images on the internet, if the size of the image is large, then it requires more amount of bandwidth and it also occupies more amount of space in the server. For example, if you consider this image, it comes under image compression. There are different types, lossy and lossless image compression. We are seeing here lossy image compression, and this is the input image for this compression block. If you see this input image, this is the original image where its size is of 824 KB. After compressing that particular image using this compression block, some compression technique will be used in that block, and it have been reduced to 50%, and the memory size of the image is also being reduced. It is 76 KB. So if you are reducing still that to 80% using this lossy compression technique, it is reducing to 38 KB. So we can use different compression techniques in order to compress the image so that the area occupied by the image storing capacity will be reduced and the bandwidth required to transmit these images also will be reduced. But there is also a small limitation that we have to look into is quality of the image. So during this compression technique, we should also see that the quality of the image should not be lost. So this is the main function that will be performed in this compression using this compression block. And next block is morphological processing. So here, what is morphological processing? So this stage deals with tools which are used for extracting the components of the image in order to represent and describe the shape of the image. And so the basic morphological operations are of two types. It may be erosion or it may be dilution. So the output of the morphological image processing will be image attributes. So before coming to this morphological processing, we have seen different blocks in the fundamental steps of image processing. So the output of all those blocks will be images. But from this morphological processing blocks, the output of all the input images will be attributes, image attributes. For example, if we consider this image, it is showing how morphological process is happening. So if you give such a type of input image, if you see the output image, only the shape of that particular input image will be extracted. So it is going to represent the shape of the input image. And another important step is segmentation. So among all the steps in the image processing, segmentation is one of the most difficult tasks in digital image processing. So in order to work on this segmentation block, it will be also taking more amount of time because it is the most difficult task in digital image processing. So generally, what function will be performed in this block means it is going to do partitioning of objects. So it is the process which is going to take a lot of time. So even though if we are spending a lot of time to perform this segmentation, it is going to solve all problems related to image, because it is going to partition an image into constituent parts or objects. How it is going to do the partitioning of the image means, for example, if you consider this image, how segmentation will be performed means, first this image will be divided into these blocks. Again, considering this, especially this part, again it will be partitioned into 4, and considering this single, again it will be partitioned into 4, and again this will be partitioned into 4, and this will be partitioned into 4. So like this, the partitioning of an object will be performed in this segmentation concept, which is very difficult. Once the segmentation is done properly, we are going to get good result. And next step here is representation and description. So here are the two different terms available. One is representation, another one is description. So here representation deals with converting the data into suitable form for computer processing. That means whatever the data we are going to give for image processing, that particular data should be represented properly. So here there are two ways in order to represent the image. One is boundary representation, another one is regional representation. So here boundary representation means it will be focusing on some aspects, and regional representation focus on another aspects. So here boundary representation, generally it will be focusing on the external shape of the characteristics. For example, it will be concentrating on the corners. It is going to concentrating on the corners aspect in the image. Coming to regional representation, it is going to focus on internal properties of the image. For example, internal properties like texture of the image. So in any of these two ways, the representation of the image can be done. Coming to another term which is called description. So this description, generally it is going to extract the attributes that results in some quantitative information of interest. So using this descriptors only, we are going to classify from one object to another object. That means it is going to differentiate one class of objects from another. And the last block in the digital image processing steps is object recognition. So the name itself says this block is going to identify the objects. So the process that assigns label to an object is based on the descriptors. So the output of this block are also descriptors, that is attributes. So here if you see this image, it is an example image for object recognition. So in this image, we can see some cars are available, and also bicycles are available, and some person is riding a bicycle. So this object recognition is going to recognize different objects based on the label. So it is identifying as car, bicycle and person. So all these are different fundamental steps in digital image processing system. So here, basically the content what we have discussed here, we have taken from the textbook Digital Image Processing, which is written by Gonzalez. So in this session, we have covered what are different types of images and what are the fundamental steps of digital image processing system. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.